All right, time for the exciting conclusion. We're going to finish up with this problem. On Monday, Fred travels 300 miles east, going 50 miles per hour, 300 miles west, going back home, and also at 50 miles per hour. On Tuesday, he travels 300 miles east, going 60 miles per hour, 300 miles west at 40 miles per hour. Is the average speed on Monday 50 miles per hour? Well, let's see. So we have part A. So we know that the average speed equals distance over time. Right? So what distance did he travel? 600 miles total, not displacement. We don't care about the east and west. How long did it take? Well, to answer that, we're going to have to figure out the time. Well, we have a distance and we have a velocity. So velocity equals that distance over time. And we get t equals d over v. So we're going to divide out these. So 300 divided by 50, that's going to give us 6 hours. 300 divided by 50 again is also 6 hours. 600 divided by 12. 60 divided by 12 is 5 and a 0, so we get 50 miles per hour. What's the question asking us? Is his average speed 50 miles per hour? Let's go ahead and answer that question. Now, notice what I did here. I wrote out every single step, and I also answered the question. So, what I have here is my answer. Great. The answer is like a tiny sliver. But I also have this justification for my answer. I can go back, or you can go back and see exactly what I did, or you can have a grader go back and see the steps that you did this. Okay, so you want to make sure that you show your thought process. And I think we've done that pretty well. Is the average speed on Tuesday 50 miles per hour? We're going to go back and do the same thing. 300 divided by 60 is going to give us 5 hours. 300 divided by 40, 3 divided by 4 is 0.75, so 7.5 hours. So we'll do it again. V equals d over t. Our total distance was 600 miles, and our total time is 5 plus 7.5, 12.5. It doesn't look like it's 50. We've got a bigger denominator, so that means our velocity is going to be a little bit higher. When we plug that in a calculator, we get 48 miles per hour. So there's the answer, right? No. The question is the speed. So, no. This is all part of my justification right here. This is my reasoning, my thought process. Does Fred have the same average velocity for both days? Nice and easy. No. Answer and explain. 50 does not equal 48. There's my explanation. Alright, and then let's go on to the last problem. So I wrote myself a little note to stop here. Test your understanding. A car in the process of speeding exhibits a motion represented by the position and time tables shown. How does the table show that the object is speeding up? Well, an object is speeding up if your time interval is decreasing. Okay. V equals d over t. So how can we make this bigger? We can make this smaller, or we can make this bigger, because these two are directly proportional and this one is indirectly proportional. So how does the table show the object is speeding up? It looks like 2 seconds, 2 seconds, 2 seconds. We're not messing with our time at all. It's all equal. 32 minus 108 is 24. 72. Oh, that's not 24. So our delta x is increasing. Alright, calculate the average velocity for the entire interval shown. Okay, so that means the average is going to be the total distance divided by the total time. Oh, velocity is the displacement divided by the total time. So that's going to give us, we're going to have to add up all of these. Hang in with me for a second. Did we get 792 divided by 18? Hopefully. And I believe that shows 44 meters per second. If it doesn't show that, if I messed up my math, hey, it happens. But you should be good. Now let's go on to C. Calculate the instantaneous velocity of the object. So to get the instantaneous velocity, we need as small of a time interval as we can get. Well, each time interval is 2 seconds. So we're going to do instantaneous velocity, and it equals delta x again over delta t, our displacement over total time, and the smallest time interval that we can use up here is going to be 2 seconds. So we're just going to pick 2 seconds. Let's do that one that I already did, and I know that that's going to be 24. Because remember that delta means it's final minus the initial, right? And our final is going to be, I'm sorry, I'm trying to rush, 132 minus the initial is 108, and that's going to leave us with 24 divided by 2. So that's going to be a positive 12. We can even positive 12 meters per second. D, calculate the final instantaneous velocity. The final velocity of this instantaneous. So we're looking at this little thing over here. Is going to be the same thing, delta x over delta t. Sorry, it's taking me a minute. You got nothing better to do, right? Our delta x final minus the initial is 900 divided by 7, or minus 748, divided by 30 minus 28. That's this stuff right here. Equals 152 divided by 2. So my v is going to be 76 meters per second. Again, that's positive. We can assume it's positive, and that's just fine. Excuse me. Let's see. How do your answers to C and D relate to your answer to B? Okay, so C, what did we get? We got 12. D, we got 76. And B, we got 44, right? This 76 plus 12, divide that by the number of velocities, and we get 44. So 44 is the average speed, or excuse me, the average velocity for the entire time interval. And then we took the instantaneous velocity at the very beginning, and then we took the instantaneous at the very end. We averaged those two velocities together, and what do you know? We proved to ourselves that we were right to begin with. We got 44 meters per second. That's it. Just in time. Good luck. Go ahead and move on to your problems. Do as many problems as you can, because really that's where you're going to start grasping this a lot better.